Hi, I am Bero. I am one of the principal open source architects working on the Eclipse Foundation's Oniro IoT operating system for the Huawei Open Source Technology Center, where one of my main tasks is maintaining the toolchains. In this talk, we will find out about libc++ on Linux from the point of view of a distribution that has recently changed its STL implementation from libstdc++ to libc++. Before I tell you a bit about libc++ and Oniro, let's take a quick look at why switching to libc++ is not, or at least not yet, something commonly done in Linux systems. libc++ on Linux had a bit of a rough start. Locales weren't working initially. Sometimes things would just crash on startup if libc++ was built with GCC, and that was at a time when Clang wasn't commonly available in Linux distributions. People still have some of that in their memories. And on top of that, there's just no super compelling reason to make the switch, because libstdc++ is a good choice, and it certainly won't make anyone's list of things that need to be replaced, no matter what the alternative is. Many people still use GCC, and libc++ is a bit hard to use with GCC, because GCC doesn't have Clang's -std lib switch, so you cannot just say, okay, give me libc++ for this and give me a libstdc++ there. And it's even missing no stdlib++, so if you want to use libc++ with GCC, you have to use -no stdlibs and then specify everything from libc++ to the C library to C runtime files manually. It's doable, but it's hard, so if you want to use libc++, you pretty much have to use Clang, unless you want to hack build systems a lot. But lastly, there's the one big issue, which is binary compatibility. Individual applications can and do use libc++ on Linux for a long time. For example, Chromium bundles its own copy of libc++, but it becomes harder when there's other libraries involved. For example, if a system were to switch to libc++ and then compile Qt and Boost and the likes against libc++, a third-party binary-only application that was built on some other distribution, obviously with the version of Qt and Boost that was linked to libstdc++, will just crash because the symbols don't match. So now that we know this, what is Oniro and why don't we have to care about this? Oniro is an Eclipse Foundation project focused on the development of a distributed open-source operating system for consumer devices. It will run on all sorts of devices, from small Cortex-M microcontrollers to pretty high-end devices. But it's not a desktop or a server system where users would commonly install third-party binary-only code and not have access to source to link it against whatever STL implementation they want to use. So binary compatibility with the big distributions doesn't have to hold us back. We can move without having to wait for others to do it first, or without having to wait for others to do it at all. But we are not doing this just because we can, or just because some evil principal open source architect thinks it would be fun. There's some good reasons to switch to libc++. The code looks a lot more maintainable. It carries around less compact craft like C++98. It's a perfect match with the Clang toolchain. Oniro uses Clang 14 by default. There's no nasty surprises of the I updated GCC, but now Clang++ buffs on any code trying to include an STL header kind. I think that the more readable code, less compact craft, and the PSTL merge and things will probably result in better performance if given some more time. Another fairly big thing is that building libstdc++ outside of the GCC source tree, or even inside the GCC source tree with a compiler other than GCC, is kind of hard. So that would mean we have to build GCC even where it otherwise isn't necessary. Most implementations of Oniro use Clang and Muscle, so no need to use GCC. And we also can take full advantage of Clang LTO, which is link time optimizations. Essentially what happens when you enable LTO is, instead of getting an object file for every C or C++ source file, you get a file containing an intermediate representation And then the compiler can, at link time, take a look at everything, optimize everything in one go. Because the various different compilers have rather different intermediate representations, those files aren't compatible. So you can't just take a GCC LTO file and throw it at Clang or vice versa. So if you have libstdc++ built with GCC as a static library and you try to link something with Clang against that, it will either fail if you don't have the object files at all, or it will just not give you LTO in case it can find object code, because that object code doesn't have the necessary additional information. So after deciding this is worth trying, I flipped the switch and ran Bitbake, which is the tool that builds the entire OS, and expected to have to fix about the same number of packages I've had to fix when switching from GCC to Clang or from glibc to Muzzle. But to my surprise, it got to a working build right away. And I thought, this is less work than I thought. All my planning was false, so maybe I'll have time to do some fun extra things like doing 4 talks at FOSDEM this year. It immediately passed the "it compiles therefore it works" test, and I apologize if that phrase is patented by the QA department of certain companies making non-free, non-Linux operating system. And it even booted without causing any obvious regressions. You will probably be a bit less lucky if you're trying to do this on a large code base that is more C++ heavy, given in the embedded world a lot of projects still consider C++ and even more the STL a big no. A lot of our code is in C and other languages and unaffected by switching STL implementations, but it still looks very good. Let's see what it looks like after booting. Performance is similar to libstdc++. Couple of things slightly ahead. For example, I noticed std vector and std list being a bit faster. Some things slightly behind. Std deck and string stream looked a bit faster in libstdc++. But one really good thing is binaries built against libc++ are consistently smaller than those built against libstdc++, even though the library is smaller as well. So the entire code base, including anything using it, will be smaller when switching to libc++. And of course, that smooth transitions and good results made me curious, and I wanted to see how feasible it would be to do the same in projects that are more C++ heavy. When I think of fairly large C++ heavy projects, one of the first things that comes to mind is Qt and KDE Plasma. So that's the first thing I tried. Built everything on my desktop box with libc++, and it just works, no modifications needed. Probably this is owed to the fact that a lot of this code is cross-platform, and some other platforms using libc++ already, like FreeBSD. So a lot of projects already got their code ready for libc++ by trying to use those other platforms, which makes switching to libc++ on Linux a lot easier than I thought it would be. So with that, is it all perfect? Not quite yet. There's some catching up to do with libstdc++ in performance of a few classes, some in fully implementing C++20 and upcoming standards, and of course we have a few wishlist items primarily affecting a project like Oniro. Some things that would be useful, especially in the embedded world, is the ability to omit and split out features that aren't useful for a particular project. For example, if you're targeting a headless Cortex-M device, chances are you won't need any locale support, but that is kind of big if you compare it to the embedded space. You see, libc++ tried to implement this at some point, but unfortunately that project was discontinued. Another thing is speed versus size optimization beyond just the compiler flags. For example, sometimes you can have a fast parallelized version that works great on boxes with 64 cores. Non-parallelized simple implementation that is certainly good enough for Cortex-M that only has 128 kilobytes of memory or so. Another thing would be a GCC patch implementing something like clang/stdlib, making it easier to use libc++ with GCC. So one reason to ask for this, even though we are using Clang primarily, is that there are some projects that still don't build with anything but GCC, for example glibc, and sometimes you have to mix those with code that uses the STL, and then it would be nice to be able to use GCC and still link to the system libc++. Then last item on the wishlist would be a subset of libc++ running on Zephyr RTOS and possibly FreeRTOS and other very low-end embedded systems. But there's a couple of challenges in the way of that, like they don't implement RTTI, there's no dynamic object management with new and delete operators, no static global object destruction. So that would be a bit more work than targeting a new Linux distribution or a new BSD system, but it could still be worth doing. So that was the quick view of libc++ and Oniro. I'll be taking questions now, maybe even giving answers. And if you want to talk to us in more detail, please visit the Oniro stand at FOSDEM and our website, and find our team on Mattermost and IRC. Thank you for listening.